Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the asynchronous motor, their construction, working principle, and their types. So, asynchronous motor is one of the kind of type of motor in which the motor will not operate in a synchronous speed. Instead of achieving the synchronous speed, it will runs within a limit, which means below the synchronous speed. So, an alternating current uh, motor in which the stator is not synchronized with the rotor and is free to rotate at a speed less than the synchronous speed due to their slips. This is the main theme of your asynchronous motor. This is because the rotating magnetic field does not couple with the induced field of the rotor, which means the rotating magnetic field RMF, which produced by the stator, will not get coupled with the rotor. So, in this motor, the torque is generated when the rotor is not in phase with the stator, and the current is induced in the rotor as follows with the Lenz's law. Lenz's law in the sense the current carrying conductor placed in a magnetic field, conductor tends to move. So automatically this is the main theme of your Lenz's law. The moment of rotor cannot be synchronized through the moving stator field. Then working principle. The principle of Lenz's law, which is followed by this asynchronous motor, which states that the direction of the current induced in the conductor by changing the magnetic field is such that the magnetic field created by the induced current opposes the changing magnetic field produced by it. So the stator magnetic field and the induced rotor magnetic field get opposed. In this motor design, the phases can be connected with the coil so that the magnetic field can be generated in the stator. In this motor, the current flows within the rotor can be achieved or activated through an induced voltage from the rotating magnetic field. Once the magnetic field is applied to pass the rotor, then the voltage will be induced at the rotor. So basically the magnetic field of the rotor runs asynchronously towards the magnetic field of the stator or with some delay in time. So the delay among the two magnetic field is known as a slips. Then coming up to the basic construction of the asynchronous motor, this is the following construction of your asynchronous motor in which the outer frames are covered and the inner in which we have a stator with a three-phase winding, then rotor bars, then a squirrel cage rotor or a slip ring rotors. We can use any of them. Then grows for your stator windings and air gaps, which responsible for the rotating magnetic field production. So the construction wise, slip ring, we have a different parts as a slip ring type or a wound type, then squirrel cage type or a short circuited rotor type, then stator, in which the stator we have a stator cores, stator windings, and bearings, end shield to cover the outer frame, then the motor fans, which reduces the temperature of the rotor, and the terminal box, which supply incoming end is to be connected. Then rotor, we have two types of rotors. One is slip ring and second one is your squirrel cage. The slip ring type consists of a real winding in which the slots which is connected to the slip rings. So the rotor resistance through the slip rings and brushes are also being connected. This helps in the alternating starting of your motor. Then coming up to the squirrel cage type, the squirrel cage type also has a rotor bars on the rotor which are short circuited through a ring on the both the sides. So this type of motors has a fixed starting characteristics that cannot be altered by adding any of the extra resistors. Next, we will see the example of your rotors. This is your squirrel cage and wound type of rotor. As I said, the metal rings and the laminated cores and the copper bars, which will be presenting the total rotor structures of your squirrel cage rotors. Then the same will be there in a wound type of rotors. Then stator. Stator is the stationary part of your electric motor. This part provides the electromagnetic field, which means the rotating magnetic field required to drive the rotating parts of your motor. It is made up of number of stampings with slots to carry the three phase, and it is mainly having a laminated cores in which it will be in a separate thin sections in order to reduce the hysteresis losses. Next, types of asynchronous motor. Mainly we have two types. One is your induction type, second one is your commutator type. Induction type is further classified into a single phase induction motor and three phase induction motor. This rotor which uses in the induction motor will be further classified into a squirrel cage and slip ring type of rotors. Then then the single phase induction motor will be subdivided into a split phase induction motor, capacitor start induction motor, capacitor start and run induction motor, then shaded pole induction motors. Then coming up to the second type, commutator motor. The commutator motor is subdivided into a AC series motor, AC compensated series motor, then repulsion motor, then repulsion start induction motor. So these are all the types of your asynchronous motor. Then advantage of your asynchronous motor: it is a low cost and easy to maintain. Then the efficiency is high in a partial load due to their load dependent. uh, if the load is less means automatically your efficiency of your motor will be higher. Then they are easy to operate as there are no electric connectors to the rotors. As there is no brushes, so we don't need to care about the sparkings and explosions in the environment. Then they are very less speed variation from low to rated loads. Then key points we need to know about this asynchronous motor: the torque is directly proportional to the square of the voltage. So if the voltage get increased means automatically your torque will be higher. If the voltage is reduced due to the load means automatically your torque will be reduced. The frequency change will affect the rpm of the motor to some certain extents. If we change the rpm of this motor, uh, that will be possible only if we change the frequency and the voltage in a same ratio. As if the asynchronous motor runs in a overloaded condition means it will draw the excessive current, and even it will cause the burnt out of your motor coils. Then applications. It is mainly used in your common household areas and in a daily appliances like blowers, fans, conveyors, compressors, and heavy duty cranes, lifts, lathe machines, paper mills, oil mills, and textile industries. Then it is used in other industries like cement fertilizers industries, then pumping and conveying belts. So these are all the applications of your uh, asynchronous motor. Next we will see one practical example. So this is your structure of your asynchronous motor. It is an induction motor type. So in here, as I said, the outer frames covering the stator windings, stator coils, then the rotary parts, which means your rotor, squirrel cage or slip ring rotors. The end terminal, which covers the outer shields, then the bearings, which is connected with the shaft, and further it will be connected to the load. Then the top portion is your three phase input connecting area in which the AC supply is connected. So these are all the examples of your AC asynchronous motor. Hope you all understand. I think so. Have a nice day. Nandri, vanakkam.